Hello, today I'll be making Cobalt Tetrafluoroborate, which I'll use to make various cobalt complexes later on. First, I measured out 26.61 grams of boric acid. After that, I measured 172 grams of 20% hydrofluoric acid. I'll need both of those to make tetrafluoroboric acid. The reaction is very simple. 4 moles of hydrofluoric acid react with 1 mole of boric acid to form 1 mole of tetrafluoroboric acid. Due to the extreme stability of the tetrafluoroborate ion, it has to be carried out in an ice bath. I also pre-chilled all the reagents to 0 Celsius to make sure that none of the acid boils during the reaction. I added the boric acid in small portions, making sure all of it dissolved before I added more. The interesting thing about this acid is that due to the fluorines attached and the high electronegativity not allowing any electron pairs to detach, it is extremely non-coordinating, which makes it perfect for complexes, as the anion won't interfere in the complexing process. After all the boric acid has been added, I let the mixture to stir in the ice bath for 1 hour and later at room temperature for another 12 hours. Now it's time to prepare the cobalt hydroxide. To 56.6 grams of cobalt chloride hexahydrate in 300 milliliters of water, I added 20 grams of sodium hydroxide in 100 milliliters of water. I recommend doing this after you have prepared the acid to avoid any of the hydroxide oxidizing into the black cobalt oxide. The mixture briefly turns purple and then blue as more of the hydroxide precipitates. After all of the hydroxide is precipitated, the mixture turns into a blue mush. I transferred all of the hydroxide into a 1 liter beaker and washed it with water to get rid of any leftover salt. As the hydroxide settles, we can see the alpha form of cobalt hydroxide, which is actually not a polymorph of the beta form, since it contains other ions which form a complex compound, in this case the chloride ions in its structure. As time passes, the ions go into solution and it turns into the beta form, which has a pale pink color. After it settled, I washed it out with water multiple times to get rid of any residual ions. After that, I turned on strong stirring and slowly added the tetrafluoroboric acid to the cobalt hydroxide to form Cobalt Tetrafluoroborate. In this reaction, I used excess cobalt hydroxide to avoid releasing any hydrofluoric acid when isolating the compound. So in the flask there's black cobalt oxide floating around, which is why the solution appears slightly brown instead of a clear red. The cobalt oxide is very fine, so it takes a while to settle, but after it does, I decanted the rest of the solution into a separate beaker. I tried to filter it through cotton. However, it's so fine that nearly instantly clogged the cotton and made it impossible to filter. I also tried with normal coffee filters, but the cobalt oxide just passed right through them. The final step in the synthesis is just reducing the volume of the solution and slowly drying the precipitated Cobalt Tetrafluoroborate. I evaporated the solution at 45 Celsius and dried the final product at 30 Celsius. If you plan to do this, make sure to stir it strongly to avoid any hot spots and avoid decomposition. The product is Cobalt Tetrafluoroborate Hexahydrate, a red powder. It's hygroscopic and very soluble in water and alcohol. It loses water fairly easily, turning into a purple-blue lower hydrate at 30 to 40 Celsius. Thank you for watching. In the next video I'll be making pyridine complexes of cobalt.